I'd like to start this presentation off by sharing two facts. The first, what is 3D printing? Now I'm sure most of you have heard or even seen this new technology in action. It's all the buzz in the world of technology today. Well, 3D printing is a process by which a physical object is made from a three-dimensional digital model. This is done by layering many thin layers of material on top of each other until the object is born. Now the second thing I'd like to share with you today is an average of 21 people die each day waiting for transplants that can't take place because of the shortage of organs available for donation. The rest of this presentation will be dedicated to telling you what these two seemingly random facts have in common. First, a history lesson. How did it all start? 3D printing technology first appeared as early as the 1980s. It was first used as a way to create quick and cost-effective prototypes. In the mid-90s, the field started to diversify into two distinct groups that we see today. The first revolved around 3D printers that kept the focus on improving concept development and functional prototyping. These developed specifically as office and user-friendly, cost-effective systems, in the same vein as the precursors to the desktops that we all use today. The second group was geared toward the high end of 3D printing, which is still very expensive. These systems produce high-value, highly engineered, and complex parts, and development of this technology is still ongoing and growing. But the results are only now really starting to become visible in production applications across aerospace, automotive, and medical fields. Now some more history, this time on organs. The first human organ transplant was a kidney transplant, performed in 1954 by Dr. Joseph Murray, who went on to win the Nobel Prize for his work. The first heart transplant was performed in 1967 by Dr. Christian Barnard. Now the donor of the first kidney was the identical twin of the recipient, and therefore there is no fear of immune rejection of the organ. The recipient lived for 8 years following the transplant. In contrast, the recipient of the first heart transplant lived only 18 days. But the patient didn't die because the new heart failed. He died because of the pneumonia he contracted due to his weakened immune system being compromised by the anti-rejection drugs he had to take. Now here lies one of the biggest problems with organ donation. The attempt of your body to reject that invading mass of tissue. It's never seen it before. What's it doing? Even though it's there to keep your body running. Despite the side effects and costs, organ transplants have become common enough that the shortage of donors is now the key constraint for organ transplants. As of 2011, there were over 100,000 Americans waiting for a donor organ. Of those waiting, as I said, approximately 21 die each day. Now in 2011, a milestone was reached as medicine attempted to circumvent the problem of rejection with the world's first transplant of a regenerated airway using a synthetic scaffold. The patient getting the transplant didn't need to take the lifelong anti-rejection drugs because this airway was grown from her own cells. And because the scaffold was made in a laboratory, the patient didn't have to wait for a suitable donor to become available. It's through breakthroughs like this that open the possibility that the waiting lists for organ transplants could be reduced or even eliminated. So what would it mean if we could print our own organs? How could it affect organ donation? Well, 3D printed organs would be grown from your own cells, therefore there's no chance of rejection. 3D printing would allow for the design of the needed organ through highly precise cell placement and high digital control of speed, resolution, cell concentration, drop volume, and even the diameter of the printed cells. Organs could quite literally be printed to your own size and specifications, tailored to a perfect fit. Patients would no longer wait years hoping for someone else to die just so that they could live. At this point you might be thinking, what's the problem? Let's get to it. Well, as with most things in life, it's not that easy. 3D bioprinting is very complex. So far, scientists have successfully engineered 3 categories of organs: flat structures such as skin, tubular structures such as urine tubes and blood vessels, and then hollow structures such as the bladder. Now to name just a few of the components involved in making any of these structures, there's the choice of materials. The actual cell types, for example. The heart has multiple types of cells. They all perform different tasks and they're all essential to proper function. They have to be arranged in the proper order to the right depth, all constructed perfectly. Not to mention the technological challenges faced that are related to the sensitivities of working with living cells and the actual construction of these different tissues. The cells must be provided with a system to facilitate oxygen and gas exchange. They must be constantly surrounded by the proper nutrients, growth factors, and they must have a waste product removal system, otherwise they're going to die before they ever reach your body. The most complex organs, of course, are solid structures such as the kidney, liver, and heart. Some of the challenges we face with these organs are learning to grow the billions of cells required for these organs to survive. as well as learning how to best supply the new organs with oxygen until they're integrated with your body. Here you see a beating heart. This structure, in all its complexity, is aptly at the heart of life. Its function, something that most of us rarely even observe on a conscious level, beyond, say, feeling our own heartbeat, is at the base of all of our bodily functions, whether it's delivering oxygen to your brain so you can think, or tell your hand to lift up to wave hi to your friend, or acting as the carrier system for important nutrients needed throughout the body. Us animals could not exist without it. Creating a working, beating heart to transplant into patients would be the crown jewel of regenerative medicine. How far off are we? Well, according to Dr. Anthony Atala, one of the leading experts in the field, when asked about the timeline, he said, "Science is unpredictable, so it's impossible to say for sure, but I think we can safely say that the time frame required to routinely print and implant complex organs is decades rather than years. While we may still be a long way off, everyday advances are being made to bring us closer to this goal. There are many cutting-edge and very interesting projects with different applications that are contributing to this." Now, what are these other applications? How could the 3D printing of organs advance science beyond just organ donation? A new project has come to fruition that I think is personally very cool. This product is called Body on a Chip. Here you can see the layout for each of your major organ systems on a schematic. The aim is to print your entire organ system onto a 2-inch chip, all connected by a blood source just as they are in your body. This would enable companies to perform better drug testing. The 2-inch body on a chip would represent a realistic blueprint of all our major organ systems with a mini heart, mini organs. This could create a testing ground for understanding how the human body might react to dangerous diseases, chemical warfare agents, and the new drugs developed intended to defend against said biological or chemical attacks. Technology like this could replace animal testing as we know it today, as well as save billions of dollars on dead-end drugs that fail once they get to human trials. Other applications of 3D printing in the medical field include customized implants and prosthesis, formed specifically for that person from a digital model. Individual and customized anatomical models for surgical preparation. Here you see a neurosurgeon practicing on an exact replica of a girl's brain. He's able to run through the entire surgery start to finish, knowing where the structures of her brain lie, how thin or thick they are, and most importantly, he's able to do so without the risk of harming the patient. Scientists are even studying printed cancer cells that mimic the behavior, size, and shape of tumors, observing and testing new drugs on them. 3D printing is the future of many fields. Its application will be seen across our communities for years to come, particularly in medicine. I hope you're all as excited as I am at the possibility that that future holds. Thank you.